So Venkat is going to be just like maybe giving a quick overview about the last session, and he's going to be spending some time on checking like any questions, any maybe any issues with the previous session. Then he'll go from there. Venkat, thanks again for taking time and also like sharing your wisdom.
My pleasure, Vamsi. Thank you for giving me this opportunity. So let me share my screen. Are you able to see my screen? PowerPoint with S3 security?
Yes, Venkat.
Wonderful. So good evening, everybody. So last week we spent decent time, about 90 minutes or so, talking about we kicked off this journey to AWS certification. It's not just specific to one certification. In fact, it was mainly intended for architect certification, but it's the same, pretty much same content for others also. There's some depth that varies among the certifications. I'm not talking about the specialty ones like big data and others like networking. But in general, the concepts are pretty much the same. So first 10 minutes or so. So I just wanted to take this 10-15 minutes to make it conversational, and then see. Before we talk about the next level of topics, today I'm planning on talking about RDS and VPC and CloudFront. So before we talk about that, I'm sure we'll make it conversational also, but do you have any questions so far based on, the concepts that we talked about, like a global infrastructure, IAM or EC2 or S3, anything that you wanted to bring up?
One question, Venkat.
Sure.
We spoke about EC2 in the last week. It's correct me if I'm wrong. This is like an elastic pool in Azure, right? Where you don't have to configure each and every DB. You will be buying a pool and adding all the DBs into the pool. Is it the same concept?
So what is this called? Elastic pool in
Elastic
Azure?
pool in Azure, yeah.
So
sorry, I don't know much.
No, that's fine. That's fine. What is it? Can you tell me in one sentence what it is?
Yeah, elastic pool is basically like you are buying a pool and you don't have to configure each and every DB with standard premium. Instead, you are buying a pool and paying for the pool, and pool has the capacity, and you are configuring all your DBs to the pool. That's what the elastic pool means.
Configuring all the DBs to that pool.
Yeah. So it's just cost saving.
Sorry, go ahead.
It's just cost saving mechanism for
I see.
For all the DBs. Yeah.
So this one, EC2 in general, it's not specific to that. Mm-hmm. Okay. So EC2 is a broad name for all the compute services that Amazon provides.
Got it.
So it's the compute service. EC2 stands for Elastic Compute Cloud. Mm-hmm. It's for the compute service. S3 stands for Simple Storage Service. That's a storage solution. Okay. So EC2 is all about computing. So how do you spin up your virtual machine essentially?
So do we have something similar to what I'm saying in AWS, where you buy a pool instead of buying each and every DB? You are buying a pool and configuring all your DBs to the pool.
So that's where I'm thinking. So is it specific to database though?
Yeah.
Oh, this concept is specifically to database.
Database, yes.
Okay. So then let's wait on that.
Sure.
If it's specific to database, then I'm going to talk about a concept called RDS, Relational Database Service. So that's where, let me not jump the gun.
Yep, definitely. Sounds good.
For 10-15 minutes, we'll talk about that.
Perfect.
So it's a managed service. Okay. But as far as the compute sources are concerned, so we have at the high level, if you look at it, there are multiple categorizations here, right? One is the compute services. So the compute service is EC2, and S3 is the storage service. Okay, object storage essentially. And then all the databases, they come under another service section called RDS, Relational Database Service. Okay.
Got it.
And today we'll talk about another service called CloudFront, the CDN service. So, and then we'll also talk about a concept called VPC. That's the networking service, where you will get the, the complete control over underpinnings, pretty much.
Got it. Sure. Yep. I don't want to jump the gun. Yeah, let's go.
Yep, we'll do that. No, thank you.
Thank you.
Thank you.
A quick question. I'm
Sure.
like not about technical, not about maybe architectural, but in general, if I want to learn all aspects of the billing of AWS, right? So where would be my place to go and find things and learn about them? So usually, like I want to go to companies and challenge. Pay me only if I save money on your AWS services. How I can I'll show you how to optimize.
Right.
So if I want to learn that, how would I what would be my approach on gaining knowledge?
Right. Right. So there are a couple of aspects here. That's a great question, actually. So a lot of companies are going to cloud with the assumption that it could be cheaper, but they end up paying
more.
They end up paying more, unfortunately. Again, as I said in the past, it's not because of the sword; it's because of how you use it. It's it's essentially, it's not architected right. Okay, it's pretty much, you build a Ferrari and put it in garage. Essentially, so you have your C4X large, without knowing. I know I've been there, actually. I've been myself there. If I go back in time and then re-architect some of them, I would have completely architected differently. Okay, and even in my current company, I was saying, so just because of our 5-6 week, of course, we are not on cloud. That's a different story. We're going there in this current company for the last 3-4 months. So the one example I was giving is that just because they have, they want to run the load test that matches the busy season that runs only for 4 weeks in the entire 365 days. So they run the replica of the production environment. We have about 130 servers. So we run the same. We have a replication going because we wanted to simulate what exactly happens in the 2020 busy season load. We'll take that 2020 busy season, we'll multiply it by a factor with based on the industry numbers. They say that let's probably the load is going to be 1.5 times 2020 peak load will be in 2021. So and then based on that we wanted to do it. So for that 4 weeks, you are actually keeping it for all 365 days. That's just one example.
Right.
And then, okay, I'll answer your generic question. The generic question is AWS budgeting, and there is something called AWS. It's called, so if you have multiple accounts within an AWS, right? So you actually, the bill goes to different departments based on how you set up your labels. Okay. So you have multiple AWS accounts and each one must be paying something. Okay. So what you need to look at it is you have to look at the consolidated amount. Okay. So the consolidated, the bigger picture of this one. Okay. So the lot of times, in my opinion, what happened, Srinivas, was they were cost center driven. So everyone was looking in silos. Okay. So the finance was thinking in a silo department that I need 60 EC2, let's say X4 M4 large. Okay. So and then they always have these instances running. Okay, they're paying for 365 days, 24/7. Unfortunately, okay. So they are not leveraging this. There is a concept called auto scaling group is definitely one of them. but there is a concept called cloud formation template.
Okay.
So with a cloud formation template, it's a true power command. Pretty much you can write your code. So the entire infrastructure, entire QA environment, for example, can be spun with a simple script.
Okay.
Okay, it's called a cloud formation template. So you can write a simple, shell script like template, create an application load balancer, and then create a security group and attach to the application load balancer. Create another security group and attach spin up 10 EC2 instances with this much configuration and attach this security group to all of them.
Nice. Okay.
Okay, so you can spin up it. So, and that's one way of it. And then auto scaling group is another beautiful way of it. If you cannot re-architect your whole application, this is where a big asterisk there. If you cannot re-architect it, but if you are architecting in 2020, I want to challenge all of us to think in serverless direction. Think in terms of event-driven architecture, EDA. So make it as asynchronous as possible. When an event gets triggered, okay, so this guy will say that somebody placed, let's say I'm running an Amazon like website, okay, somebody placed an order, and then this guy using something like a simple queue service, SQS, I'll post a message into the queue, it gets triggered, okay, and then there is a topic attached to that. And I'll say that, hey, there is an order placed, okay, and then all these listeners will actually actively be listening to that. All these simple lambda functions. You don't have to pay for lambdas unless that compute is actually utilized. So the difference between EC2 and lambda is that I'll tell you guys, everybody. So the difference between EC2 and Lambda is that when you spin up an EC2 instance, you are paying for the entire 365 days and 24/7.
Okay.
But within that 24 hours, let's say, you get only requests for 30 minutes, but that 30 minutes, you will get intensive load. Okay, you have to do some heavy computing. Just because you have that requirement for within 30 minutes, you don't have to have your server up and running all the 24 hours. That's where the lambdas come into picture. You just raise an event and then trigger your lambda function. And then lambda function, I know we didn't talk about containerization. Probably we'll talk in the next, the next session. So one is containerization, but beyond containerization is complete serverless. Pretty much you don't care that lambda function, your piece of code will get triggered when some event, your piece of code will get executed when events get triggered.
Okay.
So by leveraging some of these application architecture principles, if you can rewrite it. Otherwise, what you can do is, you can go with the spot instances, you can go with the reserved instances. If you know that you have a steady load of if you have your steady traffic all the time, okay, let's say through your load testing and performance testing, you found out that you would need about 70 to 100 instances all the time.
Okay.
Then don't go for ad hoc. Go for reserved instances. Pay upfront for all 3 years. You will get up to 70% cheaper.
Oh, nice.
If there are any scheduled jobs that run in the night time, okay, within that range, go for spot instances, bid your price, okay. If you have a little bit flexibility, if it absolutely have to run at the same time, then it's a different story. Then you can go for, quickly using your automation, something like a cloud formation. You can spin up your instance at midnight, okay, at 12:30 or 12:15, let it warm your instance and then run your 4 or 5 hours job and terminate it, or even at least stop it or hibernate it.
Right.
Then you will not be charged.
We are shutting down our GD instances. They're only US based, so we shut down in the night every day. So
I see.
I think a lot of people are trying to do the shutdowning in the evening, shutdown at night, or in the QA environments also invoke it when you get a request.
Exactly.
and create the instance when you got it, right? Like
Exactly.
so.
You do not want to have your instances running in your, just the same example. You might need your, what is that? M4 large, big Ferrari like instances. You don't want to keep it in your garage. You always want to, leverage it as much as possible, right?
I think overall in conjunction is like we need to include cost is a big aspect in the mindsets. When we are moving from the regular programming to the object-oriented programming, you need to shift your whole brain to object-oriented, right? The same way when you are moving from the data centers to the cloud, like you need to adopt the mindset of the cost controlling.
Very well said. Yes. So cost is, epicenter of any architect's, any architecture. Pretty much, you'll have to architect around that. I mean, that's one of the concerns. Okay, and of course the availability.
Yeah.
So you'll have to take that into concern and always be prepared for errors, especially in cloud. Expect that things will go down. Expect that things will always go down and architect around that. Invariably, your availability zones do go down.
Yeah, even if in the case of 99.95, right? So it is like a half hour a year. So still that half hour is countable for
absolutely.
So yeah, if it happens during your peak time, you can't help.
Yeah. And since we are talking in general architectural principles, right? At the time of deployments also, think about it. Maybe you guys are doing AB kind of deployment, blue, green, red, black kind of deployments. So maybe you have a pool of servers sitting out there to take the traffic from the other one. Put it in warm state. Okay, put it in hibernation mode, or keep them stopped. And then based on event, bring it up and do it. So this is my own experience, okay? Of course, we kind of, later we changed it. Actually, we did not end up changing it. So we had, by SLA, by SLA, we had to have our disaster recovery in a completely different region. This is not a completely different availability zone. That is different.
Yeah.
We needed to have in a different region. So we had our primary in Virginia, and we had our standby, our DR in Oregon. Okay. And to tell you the truth, this replica, all these servers were actually active in the other state. They are ready to kind of take the traffic. Of course, we had another SLA called uptime should be 99.98, which means it's 8 minutes downtime in a month. So to cover that 99.98, meaning you can be down for only 8 minutes in an entire month. You cannot be down more than that. Because of that, we had to keep them in a warm state in the other side of the country. But if we don't have that, we could have very well put it in cold state. Anyway, this is an active standby architecture. It's not an active. Does it make sense? So in an active standby, sorry, go ahead.
I was about to ask that, like, if requirement is too, kind of like that kind of requirement, why can't you make it active and put it auto scale, like everything routes to one region?
Right. So there are some reasons why active was not possible because of your relational database.
Oh, okay. Gotcha.
So not all relational databases can support active architecture.
Yeah, got it.
Some of these non-relational databases, they do support active.
Yeah.
But
I got you.
Or you have to go for, if you're using Oracle, you have to go for something like a Golden Gate or something.
Yeah.
I don't know. Even in case of Golden Gate, I don't think your standby is available for you to read. Does it make sense?
Yeah.
So you'll have to take that into consideration. It's an awesome discussion.
I have one question, Venkat. Like, I mean, like, I'm in the event-driven architecture from last 10 years. I mean, we follow different patterns and different bus architectures and different patterns. And size of the JVMs are changed in every time. But when it comes to serverless, right, like it's like almost like a micro kind of thing, behavioral functions, right? So, I mean, I had two fundamental questions. Is like, once if you go too much into the the serverless, if I want to move to the different cloud platform or a class platform, right? So then it will become it's too much effort to move.
That's a great point. You are tightly coupled with a public cloud provider.
Yeah.
Yep.
That is one thing. And second thing I'm seeing is because of spreading across like so much of serverless, integrity will become like a little bit problem of the integrity of the whole end-to-end.
I'm with you. I'm with you completely on that. And debugging will be nightmare as well.
Yeah, support will be nightmare.
Amazon provided this service called AWS X-Ray. So X-Ray will give you the complete the request path, pretty much, from the point your API gateway or the front gate takes the request, where and all it's going. Okay, what's the payload looking like? Who took the next after API gateway handed over to, let's say, Lambda. Okay, what exactly happened? Okay, after that, second Lambda has been called. Sure. After that, where exactly? So you'll be able to, using X-Ray service, you'll be able to do it, but still, it's a nightmare. Okay, I can tell you that. So that is why, the architect job is crucial here, right?
Yeah.
It's not about just because you have a hammer, don't look for nails. Just because you learn about,
exactly.
serverless, don't think that it's a silver bullet for every single use case. It has its place.
Yeah, exactly. I think that's what I was also coming there is like, so once you are in a cloud platform, like look for, previously we used to think like, okay, majority of business cases, some maybe follow this pattern, even best architecture, everything used to be like 100% used to be like that. So now you are in cloud platform, like stitch what you needed for every scenario. And it will be a suite of products and suite of patterns and suite of things like, but end of the day, you don't need to follow same thing for everything.
You precisely nailed it. There is no silver bullet. And please, just because you have a hammer, don't look for nails. Just because you have something in your tool set, please don't start looking for it. You just, there's no such thing called, in the industry, IT industry, they say that, right? There's no such thing called best practice. Everything is a contextualized practice.
Exactly.
So there's no such thing called best practice. Whatever worked for you may not work for me. So that's why if you look at any of your, ranging from your Deepak Kalur's core JTE pattern all the way till, he always puts the first paragraph is context.
Yeah.
What context? What's the problem domain? What's the solution domain?
Exactly.
Always go for that.
Can I ask a quick question? Sorry. So,
no,
for serverless.
I have questions. I don't have answers. Go ahead. Sorry.
Okay, got it. So, for the serverless, right? We are saying, there is a tight couple of dependency with public cloud providers. I agree. Once we design, we may not be able to run it in on-premise. But for example, if I design a serverless application in AWS, I should be able to move it to GCP or Azure, right?
I will add a point there. You are right. We were right in a way, but I'll add a point there. So AWS has this concept of Lambda. We all know that it's a function as a service, right? And Google has something called a cloud function.
Right.
Okay, so both of them have it. But the problem is, if you really look at it, let's say we talk about Java. So AWS has given, AWS Lambda core is one of the libraries it provided in Maven repository. Okay, you will put that as a dependency. Okay, and then you will have to implement AWS specific interfaces and then write the methods there. Now, unfortunately, you are coupled with it. When you move the same piece of code to Google Cloud Function, you will have to change. Whether now you can argue that's not a big deal. I'm with you. It can be big deal, cannot be. It depends on the context.
It's not that you can't move it, but you can move it, but it's more work. It's not simple.
You will have to touch the code. I even want to make it more generic. I don't want to say it's more work also. I want to say some work. How about that?
Yeah.
Okay.
Because you literally.
Do you agree? Or,
yeah, makes sense.
Because you're literally going into the function level, right? Like, so assume that you have like 1,000 functions. Now managing those 1,000 and maintaining the integrity between those 1,000, when you're moving 1,000 to a different platform, I feel like it's a little bit more work, right? Like, so compared to like moving a JVM or moving a Docker image, or is comparably large.
Yeah, like you said, right? I mean, in case if you have a Docker image, like a container based and all of that, right, it would be easy to move across the platforms. Maybe that is missing in serverless world.
Yeah, you are right. So if you really look at, I know we are not there at the containers and the serverless. So in the evaluation, if you really look at it, so you have back in before 2006 and all, you had these physical servers, right? And later on, we had this concept of virtual machines, right? With the VMware and other stuff. So you have a virtual machines. Now from virtual machines we went into the next level of containerization. Hey, I don't need a virtual machine for every single of my Spring Boot app, let's say. Okay, I don't need this burden of additional operating system, right? So I have a bunch of Java applications. Why do I need virtual machine for every single one of them? So I can actually, I can create the Docker, the Docker container, the Docker engine, okay, and then I'll deploy my Spring Boot apps there. Okay, so that's a container level. There also, I know you are not dealing with any of the servers there, but you're dealing with the containers and scaling up the containers, scaling down the containers. Either you will be using, some container orchestrations like Kubernetes, or like Fargate or Fargate acts as an abstraction, on top of ECS and EKS. But one way or the other, you'll have to manage these containers, right? Agree that's a much what do you call that? Much lighter than virtual machines. Much lighter than virtual machines, right? But still you're managing it. But when you go to the next level, function as a service, when you go to that, pretty much there is no concept of container. I mean, behind the scenes, it does the same thing, but you don't have to worry about it. All you say is, I want this, I want to create this Lambda, and I want to assign 256 meg of RAM for that. No CPU, nothing at all. You don't care how. It's somehow magically, when a request comes in, it will create a small, lighter weight container under the hood. You don't have to worry about it. How many containers or any of that, whether it's reusing the container or creating a brand new container, you don't have to worry about any of that. So if you really look at it, it's serverless is sort of a bleeding, but before that you have the container. So if you want this, portability across these public cloud providers like Google, Azure, and Amazon, in that case, then go for containers. Because going back to the virtual machine is probably not a good idea.
Yeah.
Right.
Go with the containers and go with something like Kubernetes. Kubernetes is supported by AWS. It's supported by Azure. It's of course, it's inherent in Google anyway. That's Google's.
Right. Agreed. Makes sense to go with the container model if we have that kind of concern. Agreed.
So there is no sticking point to that. You are not stuck with one cloud provider anymore now.
Yeah, exactly.
Right.
There is vendor locking.
Yeah. But again, Google Cloud Function has its benefits. All it means is you are using a different library and implementing a different interface. But once you enter into that, pretty much it's the same thing.
Yeah.
Got it. Awesome.
It's a trade-off. That's the architect's role. Biggest role is always day in, day out. Every decision is trade-off. There is no black and white solutions out there.
Yeah.
There's no right or wrong. Contextualized practice. There's no such thing called best practice. Going to that mindset, whoever has not played that role, I'm telling you, there is no such thing called best practice. Everything is a contextualized practice. Whatever works in one company and one context may not work in different contexts in different companies.
Very well said. Thank you.
Yep. Thank you. That's a great conversation. That I'm humbled. Love you guys. Okay. So if we can proceed. So we talked about EC2 and S3. In S3, I did not talk about a couple of concepts in the last session. So I'll start from there. Okay. So we talked about encryption types. Going into the exam, it's very critical to understand these three things on the server-side encryption. Server-side encryption S3, SSE KMS, SSE, which is customer-provided key, and of course you have a client-side encryption. Go to the exam, very critical, please. And the next one is S3 pre-signed URLs. Going into the exam, in general, also understand the concept, but going into the exam, it's important too. So what exactly is a pre-signed URL? Well, you have an S3 bucket. Inside the bucket, you have an S3 objects, and each object has an object key. And of course, you have your object contents. So we talked about bucket policies, the security policy at the bucket level, or we also have at the object level ACLs, access control lists. So my requirement is, I don't want to make my objects public. I want to make my objects private. And then once user is logged in, now I want to give them only for the logged in users. Let's say I'm the best example. I'm in the training, training business. Okay. Next step that training is I'm doing AWS training and a lot of my videos. So I upload my videos to S3 bucket. And I want to give access to my paid students only. So once you are logged into my application, let's say I have an application, and once you are logged into application, what I can do is using the application and using because I'm the author of that S3 objects, right? So I will use my credentials, and then I will sign. There is something called pre-signed URL. So I will pre-sign that particular object. I will pre-sign that particular video, okay, with my signature, and then I'll put it expiry date. It expires in the next 15 minutes, let's say. And I will give that the signed URL to my logged in student. And now I'm not in the middle. Once I give him the pre-signed URL, now he will be able to get the content directly from S3 itself. I'm not in the middle. I'm not streaming. I'm not taking the object from S3 and giving it to the user. He can go directly to S3 and get it. And I know that he's logged in because I'm the one who pre-signed that particular URL, and I gave the pre-signed URL. And once he stopped watching it, I know that URL will not work. He will not be able to share that URL also. That's the concept called pre-signed URLs. So keep your buckets and objects private. You do not have to expose it. Grant others time-limited permission. Okay, you can provide your expiry. It could be 10 minutes, 10 seconds, 20 seconds. Okay. The beauty here is that I understand, I want you to understand this one here. Beauty is that your application is not in the middle. Your application is signing it to a private object that is sitting in an S3 and giving it safely to your authenticated users. And they are able to go directly to S3 and get it. So no one is compromised. This is beautiful. And what do you have to do? What is the other solution? Unfortunately, you'll have to be in the middle, meaning you have to go continuously stream it. And then, okay, since he's logged in, okay, let me be the middleman. And then, I'll take the content from S3 and then keep providing it to the user. That's silly. So you can use this place. Yeah.
A small question here. Buckets and objects private. So if we make the bucket itself is a private, all the objects are going to be private, right? Do we need to make both the, things are private?
That's a good point. So you have a bucket, and inside the buckets you have objects, right? You can keep the bucket as private, but you can use your object level ACLs to give them specific permissions, including you can make them public, certain objects within a bucket. Absolutely, you can do it. Those are object level access controllers.
So if you use the object level access controls, then buckets should be public.
No, you don't have to, because you are dealing with, it doesn't matter what the bucket level permissions. Bucket level permissions are across the globe. Okay, if I want to, best example is my static website. In my static website, every single file, every single HTML file, CSS file, JavaScript file that I drop it into my bucket, I want them to be public.
Yeah.
Then I will write a bucket policy in such a way that every single object within this bucket is public. I don't have to deal with the single object's ACL anymore. Does it make sense?
Yes. I understand. You told that buckets are going to be global in last session. I remember. Thank you.
Yep. So time limited permission, you give it with an expiry date, that URL. And how do you create this pre-signed URL? Well, since you are the author, using your credentials, you can very well use your SDK to do it. Of course, you can use your CLI to do it, but CLI, you have to have your command line interface, and then, okay, you generate it. It's good for testing and it's good for, to understand the concept, but that's not what you're going to use in your application. You'll rather use your, let's say if it's a Java-based application, your Java code, your SDK, you'll use it, get the object key and get the object S3 URL, okay? And then pre-sign it and send that URL to the user, and then say, and pass your HTTP redirect, and then say, go to that URL to get the video. It's as simple as that. So yeah, I think I mentioned it. This is a very good architecture versus streaming through your app. So you do not want to be the middleman and then stream across, take the content from S3 and sending it to it. No, rather put a time limit on your signed URL, and then have user directly go fetch it from S3. Make sense, guys? So if you want to do a pre-signed URL, how do you do that? Being an author, being the author of the object, use your security credentials, meaning in your SDK, and then bucket name, of course, your object key, your bucket, the combination of bucket name and object key will give you the complete S3 URL, right? As you guys may know that. And then HTTP method. You may be thinking that pre-signed URL is only for HTTP GET. No. It's good for, you can have user upload the object also using pre-signed URL. So you can specify what HTTP method you want to allow it. Maybe HTTP put, absolutely. So HTTP GET, of course, it's allowed, you know that. So you also provide your expiration date and time of the URL, and construct your pre-signed URL, send it to the user, and have user go directly fetch the video from S3. Any questions on that? Simple concept. I wanted to mention that. I forgot in the last lecture. Okay. So going into the exam, understand that S3 pre-signed URL. Now let's talk about Amazon CloudFront. You people might have heard CDN, the Content Delivery Network. It's not, it's not specific to Amazon. It's not specific to cloud. The CDN has been there forever, for the last couple of decades. So there are a lot of good CDN vendors like Akamai exist for a long time. Okay, so CDN, what's the concept of CDN? Content Delivery Network. Well, so you need to understand two concepts here. One is called origin server. So you have your content somewhere. Let's say you have your content is served by an EC2 instance, or your content, like my videos, happen to be there in S3, in the S3 videos. Okay, S3 bucket somewhere. So my users are all over the world. Let's say I uploaded my videos into Ohio region. My users in South Africa, they have to go traverse all the way till, using the regular internet backbone. They have to traverse all the way till Ohio, pretty much get the object and get it, right? It doesn't work really. I mean, it's, latency wise. So how can I reduce the latency here? And the popular examples are your Netflix streaming, Prime videos, Amazon Prime. So it's the same thing. Guy sitting in Mumbai, he wants to get the same experience as a guy sitting in California. Maybe the content is originated in California, but it doesn't mean that Mumbai guys have to get it all the way from California and get it. So what happens is, so you understand the concept of regions, and within the regions we have this concept of availability zones. In addition to that, Amazon has a concept of this edge locations. There are a lot of edge locations across the globe. Okay, pretty much, in Chicago, that we don't have a region or availability zone, but in Chicago, you have your ORD, right? Your Chicago airport. So they have an edge location there. Atlanta, they don't have a region or availability zone, but they have edge location in Atlanta. Similarly, in San Antonio, Texas. So you have a lot of these edge locations. So across the globe, they have these edge locations. So what happens is, when you ask for the content, if at all you're using this CDN, Amazon CloudFront is Amazon CDN service. So when you make a request, if you're using CloudFront URLs, so it will go to the CloudFront first, meaning it goes to the nearest edge location. It doesn't go to the origin at all. It goes to the nearest edge location from your place, whatever is the nearest. And then these edge locations cache the popular content in there. Let's say a brand new movie is released, or my video is released, and the first guy went there from California. So he went to, somewhere California edge location, somewhere in, let's say Mountain View. Okay. So it went there, and then the content is not there. He's looking for, let's say, Iron Man 3 or 4. Okay. And then the content is not there. So he knows what the source, the origin location is. Let's say origin happens to be in S3 bucket. So it will go to origin S3, fetches the video and cache it based on your settings. You will set, when you create, being a developer or architect, when you create a CloudFront distribution, you specify what's the time to live is, TTL. So how long do you want your content to be cached in your edge location? Let's say I want to cache it for 24 hours. So now the second guy makes the request to the same edge location. It will serve from the cache itself. It does not have to go to the origin and fetches the data, because the edge location already has your content. If edge location has it, it will serve from the cache. Otherwise, it will go fetch from the origin, gets it, serves to the customer. In addition to that, it will keep a copy there. It will in the cache, so that the next guy, only one guy, the first guy will take the hit, and from the second guy onwards, everybody super fast. So that's Amazon CloudFront. It's a CDN service, content delivery network service, and it serves both HTTP and RTMP, or flash-based media services. It does for both. It does with low latency because it serves the cached content. Okay, And of course, you can specify your TTL, and using HTTP headers, you can specify when to expire them. All of that you can do it. So content is cached in servers closer to your users across the globe. And then there are two important terminology that you want to understand here. One is called edge location. Edge location is a location closer to your users. And the other one is origin server. And that origin server can be your S3 itself or your EC2, maybe a dynamic content. EC2 can be acting as origin server, absolutely. And maybe you can have an application load balancer in between and then have it served through the fleet of EC2 instances. Make sense? Or understand here, you can have your own custom origin service also. Meaning, let's say I don't want to use any of the Amazon services. I only want to use Amazon CloudFront as CDN because I like their price. And I like their the distribution, the fact that they have edge locations all over the globe. I want to, rather than going to some other CDN providers like Akamai, I want to go with CloudFront. But origin is my own EC2 instance within my own data center. I will expose it to the CloudFront. So it can be custom. So CloudFront will go fetch it from my origin server and then cache it based on my TTL settings. So it doesn't have to be your Amazon services. It can be completely your own custom service also. I want you to understand that. So these origin servers can be S3 bucket or your EC2 instances with an application load balancer. It can be. So what I'm trying to say here is that it is not just for static content, guys. It's falsely, it's easy to think falsely that it's only for static, but it's not. CDN, using your HTTP headers and all, you can make it as dynamic as possible. So using your JSession IDs or your session tokens, using them as your HTTP headers, one of the ways to determine whether I'm serving a cached content or do I have to go to the origin server. So it's not just the static, understand that. So yep, you can bring your own custom origin, but yeah, essentially that's it. So take a look at this example here. So users are actually going into the CloudFront, and CloudFront is acting as a front door, and then it's your origin happens to be all the static content happen to be in your S3 buckets, and your dynamic content is sitting in an EC2 instances, fleet of EC2 instances behind a load balancer. So it will go based on, in CloudFront, you can specify it based on the HTTP headers, based on the request parameters, based on your URL patterns. You can specify your logic there. Based on this URL pattern, /images/ go to my S3 bucket, /rest/ please send it to my dynamic content, to my application load balancer. You can configure that in your CloudFront distribution.
I have a question here.
Yep.
The question is, suppose the moment we are we are trying to keep this static content. So do we need to choose the origin servers based on location, or does Amazon CloudFront do automatically? So for example, my server is in Virginia, so I'm trying to access the content from India. So is that if that is the case, since the latency is going to be very high, so is the CloudFront is going to automatically transfer this content to the India server, or how this is?
CloudFront is one of the few services that are global, cross-region services. So CloudFront is one of them. Absolutely, it will go, and it can go talk to an S3 bucket, which happens to be on the other side of the day. It will do it, or an EC2 instance sitting somewhere else.
So that means it does automatically.
Absolutely, it does automatically. Meaning, you will have to configure it. You are configuring your distribution here, right? CloudFront distribution.
Mm-hmm. You mean
does it make sense?
You're doing it for one time, but you're not doing for every edge server, Nara. Is that correct, right, Venkat? You don't need to do it for every edge server.
You don't need to do for every, no. Oh, that's an excellent point. Thank you, Nara, actually, for bringing it up, and I missed it. Okay. So when you configure your CloudFront distribution, the first step that it does is, it's not the content. The configuration will be distributed to across every single edge server in the cloud. The configuration that I can't, okay? So all the configurations that I've made, saying that, slash images slash go to my next step.trainings in bucket. Or if I go with the slash rest slash go to this, my dynamic content to application load balancer, right? This configuration, once I put my TTL settings, HTTP headers, all of that, the first thing that it does is it will go distributes this configuration to all the edge locations across the globe. Okay. So, now user from Singapore come in or Mumbai come in, and then it will look at it. Oh, okay. This guy came in. Okay. Do I have a cached copy here? If not, because obviously the Mumbai guy, coming here for the first time, and obviously it will not have it. It will go to the origin, fetch it, and keep it. Now go ahead. With your thought.
The thing is, we are using the CloudFront as a CDN. So in this CDN, I mean, this is not a gateway, right? So
no,
this is just a CDN.
This is not just a CDN. No, it's just a CDN, content delivery network. That's all.
So I mean to say that in this CDN, we will be having some sort of a URL filtering where it's going to be distributed the static content across the region.
Exactly.
Or across the globe.
Exactly.
Got it. So how the distribution is going to be happen? Do we have any the dispatchers internally?
So
all these is going to be one of the feature for CDF.
So all these back in 2017, I think they have 78 or 80 edge locations, and it's much more now. So anyways, all these edge locations are internally connected to your availability zones and regions through Amazon's own the backbone internet. Okay. So in fact, this guy, when you want to use CloudFront, oh, by the way, there are two points here. One is it's not only for static, you can use it for dynamic. And number two, it's not only for getting, you can also upload it. Let's say my Singapore users, they want to upload a PDF. So they will upload to the CloudFront, and from CloudFront distribution, let's say there is a CloudFront edge location in Singapore. Okay. It will use Amazon's own backbone internet, and in a super fast, lightning fast way, it will send the content to my origin, which happens to be in Ohio. Does it make sense? It works both ways, meaning you can get the content from edge location. You can also upload the content, and the CloudFront can act as a proxy even for HTTP puts and posts. Is all I'm saying.
Yeah, any transaction.
Wow.
Makes sense?
Interesting concept.
It's like Akamai, right? Like Akamai used to do a CDN business only. They don't do anything else.
Absolutely.
But because Amazon is providing everything, they are into the CDN business also. And they keep on adding more and more edge locations as and when people are using, expanding the network. And we don't need to worry about that.
Yep.
Thank you.
Yep, you're welcome. Okay. So we talked about CloudFront, and okay. So earlier, I was mentioning about S3 pre-signed URLs, right? So here, let me bring up a use case here. Now, earlier I brought up a use case where I wanted to store all of my training videos into S3 as in the S3 bucket. And I wrote my application here. The application will, create a pre-signed URL and give it to my users so that they will directly go and get it. And it gets expired in 5 minutes or so. So I told you that S3 pre-signed URLs. Now let's talk about, there is something else called CloudFront signed URLs. This is not a pre-signed, it's a CloudFront signed URLs. You can do the same thing. It's exactly the same as S3 pre-signed URLs, but the difference is that CloudFront is acting as a front gate for not just for S3. It is acting as a front gate for any of your fleet of EC2 instances, or it's acting as a front gate even for your custom, custom origin servers. Okay, so because of that, your content can be anywhere here, your custom origin server that's sitting in your data center, or your S3 buckets, or fleet of EC2 instances, anywhere. If you want to provide, if you do not want to give your content to unauthenticated users, only for authenticated users, I want to give them, and I want to give them my content only to the authenticated users, only the students who paid me. Let's say that's my use case in my hypothetical, right? Or real. So the point is, this guy will, my application will create a CloudFront signed URL and send it to my users. There are two concepts here. One is called CloudFront signed URL, and the other one is called signed cookie. Okay, it takes the cookie also. So in one of the two ways, I'm passing to my authenticated users. They will log in, and then this CloudFront will get the content directly from CloudFront, will act as a front gate and will say that, okay, are you signed? Okay, let me see your your URL. Okay, you looks like you're authenticated. Yep, it's provided by the application, the actual content owners. So it looks like you have access to, go get the content. Sure, I'll get you the content from S3 bucket, or I'll go get the dynamic content from EC2 and give it to you. So that's a pre-signed, CloudFront signed URLs. Create signed URLs or signed cookies to logged in users. You can do that. Restrict access to origin servers. Now you can safely restrict access to your S3 buckets and also to your EC2 instances. Nobody will go directly to your S3 buckets anymore. Okay, everybody, you are forcing everyone to go through CloudFront. Did you see that? Because I want them to get good experience also. Because I have a CloudFront distribution for a reason. I want to give them a good experience. I want to block I want to block my S3 buckets. I want everyone to come through the front door. When you create the signed URL, you must provide expiration date and time of URL, and you can optionally provide future date of URL when it becomes valid. You can optionally provide the future date. This URL is going to be valid from next 10 minutes from now. And you can also, with the CloudFront, the beauty is that CloudFront signed URLs, you can specify the IP range that can only access the content. You can do that optionally. Okay, so expect scenario-based questions on S3 pre-signed URLs versus CloudFront signed URL. So you can expect a question like this. I have an S3 bucket. I do not want intruders, or I do not want my students or my clients to go directly download my content from S3. I want to block that. And I want to keep my CloudFront. What do? I'll put the CloudFront in the front as a front door, and then provide CloudFront signed URLs. And that's it, pretty much. And then you block your S3. That's it. So S3 buckets now can be fetched only by CloudFront. It cannot be fetched by anyone. If someone tries to go directly bypassing CloudFront, it will say that, I'm sorry, access is denied. You can't do that. It's a simple, I wanted to show you that use case. Exam tips, I think I mentioned it to you. CloudFront is not just for static content. It's in your exam questions, you can easily eliminate some answers with this content. CloudFront is not just for HTTP GETs. You can use it to put it also. So when you put it, it goes to CloudFront. From CloudFront, it will use Amazon's own backbone internet and then super fast or lightning fast way and upload it into the origin using Amazon's own CloudFront, Amazon's own backbone. You are not going through this, all the hoops of routers in the world. Yep, expect scenario-based questions. That's it, guys, about those topics. And I have 2 more topics. How are you guys doing? Let me take a minute here.
Awesome, Venkat.
And I'll keep it conversational for a minute because I have another, 2 large topics there I was hoping to cover. But if I'm open for feedback. If you say that it's too much, anytime we can stop it. Not a big deal.
No, we are good. Yes, I'm good.
You want to keep it for a couple of minutes, conversation, anything, or I'm ready. I can jump in.
I think a couple of new folks on the call as well, Venkat. Maybe you can reach out to them and see.
Thank you, Vamsi.
Venkat, this is Amit. This was very, very useful. I think this is good. I think we'd like to go to that depth.
Thank you. I appreciate it.
So Venkat, this is Arun. The equivalent to, basically the equivalent in Google would be Bitbucket, and what would it be in Azure and?
Bitbucket,
Bitbucket would be the CDN also, right? Or
no, I mean, at least to my knowledge, no. That's your Git. That's your Git.
Oh, not.
That's a Git on the, it's a managed Git service. That's different.
Oh.
At least the big bucket that I know. If you're thinking the big bucket what I'm thinking, you have your source code repository, Git, right?
Yeah, that is, yeah, I understand that part. Either it's Bitbucket or just bucket. I think you create buckets.
That's
again, I'm still in the process of picking it up. So I believe you create buckets within for your content caching as well.
In Google.
If I understood right, in Google it is Cloud CDN, and in case of Azure it is Azure CDN.
That's what I thought. Yeah. That's what I thought. Google, it's a Cloud CDN.
Correct.
They keep it very simple. I love their naming. Google Cloud Function. It's simple. There's no fanciness there. Lambda. It's
even for Azure, it is Azure.
That's my opinion. I love it.
Yeah.
But Amazon is fancy. Fancier than any of these guys. I mean, they didn't have competition. What, for 7 years? Amazon enjoyed competition less. Being a cloud provider, the only cloud provider, unmatched. Strategically, Google took a different direction. Google went into the serverless direction to start with itself. They started Google App Engine, several years back. So they strategically their approach was different.
But I think now Azure is picking up.
Azure is definitely picking up.
Yeah.
Yep. You saw that, right? 2019,
Federal contract.
Yeah.
Correct.
Yeah.
That's
even actually 2019 Gartner, I thought I put it somewhere. No, I don't have it. Gartner, if you look at it, of course, Amazon is still way above, but after that, Microsoft is closely behind. Sort of.
Right. Mainly, I mean, with the Fortune 500 companies, right? Microsoft is leading.
Yeah.
It's because of their Office.
Right. They're already.
No, I think another fundamental difference is like if you go to AWS, right? Like if you ask leaving the technical companies like maybe Google or all the California-based companies, right? Kind of that kind of startup companies are like that kind of nature companies. Keeping them aside, anything second level companies, maybe IT is not a primary business for those kind of people. They need some level of partnership and some level of support and kind of understanding, like how IBM does and Microsoft used to do before with those guys. When it comes to AWS or Amazon, they don't do that. Like everything is there in website, go and figure it out and do it, open an account and do it.
Yeah.
But these kind of secondary companies, it doesn't work like that. So they need some technical architect to be here from the Microsoft, or somebody to be here, like some pampering they need, right? All that AWS is not doing it, and Azure is doing it. And of course, they have like equivalent products like almost AWS. At the same time, they are also capturing the market because of these reasons, because cloud is now moving more into the as like you said, like top 100 companies, which are like not only the technical companies, more are like
yeah, a lot of companies they use Active Directory, right? And that is a big
yeah.
That's one of the reasons. So Microsoft has that edge in the form of Active Directory, and they have their own the IAM solution, right? That's what is that? Azure AD.
Yeah.
They call it Azure AD.
Yeah.
Yep. So let's give minute to other people, the new folks. Thank you, Vamsi. Can you say
I have an opinion-based question. The question here, I have been seeing the LDAP almost a few decades. So, but still some of the companies have been using the LDAP. So, I mean, let's say, these sort of many features are there. So, do we think that the cloud technologies are going to be replace all these soon or easily?
Active Directory? Yeah. So
yeah, of course,
especially this
many
with,
other things. Yeah.
It's hard to say, but I can tell you. I'll give some some insight, but it's not straight relevant this one. So I'll also want to park that, if you don't mind.
Sure, Venkat.
So
sure,
my
this
view
is just
is
an
that
opinion-based question. Sorry
yeah,
about that.
yeah. No, as much I wanted to put my 2 cents. I wanted to restrain myself there. So let's see. Anyone new here? Kiran, Geeta, Deepak. Deepak was there in the last session also, I think. Right?
No, Hari, I couldn't join the last meeting, but I heard your recording.
Yep.
It was really good. And even this session, I'm enjoying it a lot.
Wonderful. Love it. Thank you for the kind words. Anyone else? Who is P? I'm just taking 30 seconds here. That's all. No. Just randomly picking, I don't know, P. Just want to make sure you guys are enjoying. That's all. Okay. I'll take it as yes. Let's jump in.
One second, Venkat.
Go ahead.
So this is a pit stop, right? Every time if you want to go fast, we need to just like maybe go to the pit stop and change our tires. I know in the last like maybe 70 minutes, you're delivering a lot of value, a lot of wisdom. How about like we all take like maybe next 90 seconds, stretch yourself. If you want to do push-ups, you want to do burpees, you wanted to do some kind of like maybe whatever you want. Get out from your chair, stretch. Some of you can show what kind of stretches that you can do in 90 seconds. Maybe Srinivas.
See you are the best. Thank you. Okay, I'm doing it.
There you go. So we are taking these pit stops not to slow down, to go faster. Keep that in mind. There you go. Shashi is doing some burpees. Excellent. Srinivas, Sindhu, Geeta, do whatever you like. Uma, Pratik. Unless if you are driving a car.
completed 15 push-ups on C.
Awesome, Nara.
Thank you.
Excellent. Venkat, looks like you're on mute.
Oh, I did 25 push-ups and 20 jumping jacks.
There you go.
I'm ready for another couple of hours.
Excellent.
Thank you for that.
Get some more water if you want.
Get some water. Yeah.
You also got it? Others?
Yep. Venkat, you can share your screen now.
Okay. So we talked about compute and storage services, EC2 and S3 respectively. And of course, we talked about CDN in the form of CloudFront. Now, let's talk about the database services. So what kind of database services that AWS provides? So AWS has this broad spectrum of service called Relation Database Service, RDS. So let's get into it. So Relational Database Service is it's a managed database service, meaning it will take an EC2 instance, like from compute we just talked about, right? It takes an EC2 instance, it installs the database service, from one of these 6 supported engines, and then it will manage the complete EC2 instance, meaning it will take care of the operating system level patches, updating it regularly, keeping it current, all of that. You don't have to worry about it. In addition to that, it will also manage the licenses for you. So when you use Oracle as an RDS service with AWS, you don't have to worry about Oracle licensing. It all comes with it. A single cost for you for the underlying EC2 instance and Oracle licensing and everything related to it. All of it, you will get one single bill. That's why it's a managed service. You will not be able to log into the underlying SSH machine. It's you can eliminate some of the answers in the exam. He will tell you that you can log into your RDS instance, the underlying RDS instance. You can SSH into it and upgrade operating system security patch. He will give you that just to mislead you. You can never do that because it's a managed database service. Okay, and supported engines also, you need to kind of remember this. It supports Oracle, Microsoft SQL Server, PostgreSQL, MySQL, MariaDB, and of course, Amazon's own Amazon Aurora. It's a super fast database. So what Amazon Aurora does is, pretty much it takes these open source engines, Postgres and MySQL. They took this source code and then they re-architected pretty much to the cloud, to especially specific to AWS. Okay, they made it highly available, highly scalable, high performant, and that's Amazon Aurora. It comes with both the PostgreSQL engine or MySQL engine. So these are the engines that it supports. Well, now when you talk about RDS database, as an application developer, you will talk about the database SQL queries and all the other stuff. But as an architect, you have to think about now bigger than that. Okay, I mean, you created, RDS instance, Oracle in AWS. How about the backups? What kind of backup strategy, does it support? So there are two kinds of backup strategies here. One is called automated backup. This is automatically taken every single night. It's a full automated backups are taken nightly based on your window specified. That's called backup window. You can specify during your RDS instance creation that, 2 a.m. Eastern time. That's my regular maintenance time, let's say, for my website. Okay. So at that time, you can take the backup. During the time, you can expect the database to have a little, high latency. Okay, for a brief period. But essentially, you can specify the backup window saying that please take the backup only this time. What it does is it takes the complete backup at that time. And after that, every single commit you made on the database, it will store as a transaction log. It will continuously save as a transaction log. So I'll give you an example. Let's say at 2 a.m., the full backup has been done. Now, 5 o'clock, until 5 o'clock, from 2 a.m. to 5 a.m., what it does is, let's say I made 1,000 commits. So every single commit, it will store it as a transaction log. So at 5 a.m., something happened. I need to revert to the database. There is some database outage, something happened, data got corrupted, and I want to put it back to as of 4:30 a.m. I want to bring a new database with the data as of 4:30 a.m. What AWS does behind the scenes is that it has a full copy of your database as of 2 a.m. From 2 to 4:30, it will apply all the transaction logs on top of it. So you will be able to recover to within a second, pretty much within that. They call it retention period. Let's say you keep your backups for 14 days. Within 14 days, you will be able to go back to any second and then say, I want database snapshot as of this minute, this second. You will be able to do that. The strategy behind that is it takes a full backup nightly, followed by transaction logs. Every single commit gets applied. Okay,
And
so
you said that you'll get back in a minute.
Second, within a second.
Oh,
it will do that. You'll be able to restore to any second within the retention period. Let's say you specify that my retention period is maximum is 35 days. If I'm not wrong, 35 days. That's you have to remember that number also. Maximum is 35 days. Within that 35 days, you'll be able to go back to any second.
okay.
Oracle Cloud, it is 60 days.
I see. Oracle Cloud is 60 days. Okay.
Default. Yeah.
I see. So here it's a maximum is 35 days. So you can set up to 35 days, but that's with the automated backup though. But with the manual snapshots, what you can do is you can take these snapshots whenever you want. So let's say it's a January 1st, I want to take the snapshot and put it out there it will automatically get stored in a S3 once you take the snapshot, right? Now I can keep it for however long I want it. I want to keep it for 2 decades for compliance reasons. You can keep it. And again, if you ever want to do it, if you ever want to get a database as of that data, January 1st, 2020, let's say, you'll be able to do that anytime. That's the manual database snapshots. So understand this name, automated backup and database snapshots. Database snapshots are user initiated and automated backups are automatically taken. Both of them are actually stored in S3. You can keep them however long you need it, these database snapshots. So in either of these two approaches, the important point you need to understand going into the exam is, if you need to restore with either of these approaches, you will have to create a brand new database. It's the same case with probably other cloud providers also, but essentially you will have to create a brand new database. So you have your snapshot. So you'll pick up the snapshot and then say, create a database with that snapshot. Make sense? That's how you recover it. So your recovered database is a brand new database with a brand new DNS name, is all I'm saying.
Which one is expensive?
Which one is expensive? So the automated backups are automatically, provided to you within the retention period. Okay, you can opt from 0 to 35 days, and both of them, once you take it, see the 0 to 35 days, it takes nightly, and then it keeps the transaction log, right? But the database snapshots, if you decide to take database snapshot every single day for the whole year, then obviously database snapshots will be expensive. Depends on the use case, right?
Depends on the use case. Okay, thank you.
Right, because if you decide to keep it for some reason, 35 days is not enough. 365 days is what I need for my compliance reasons. Then essentially you are paying for all these snapshots every single day in S3 based on your S3 prices.
Right. So it is mostly the pricing of S3 that's cost.
You got it. You got it.
The backup. Yeah.
It's a pricing of S3.
One question on the same note, Venkat. So I don't have any regular maintenance on my site, and but I do wanted to take a couple of backups every day.
Mm-hmm.
Or how does that work? Because I don't have any scheduled maintenance, and I wanted to make it.
You can pick up based on you. I'm sure you may have gotten your usage pattern, right?
Uh-huh.
Your usage pattern is there, right? So you can look at what's the least amount of users that hit your website. At that time, you can specify the window, or wait for one more minute. I will talk about there is a concept called multi-AZ, multi-availability zones. I'll talk about it. Multi-AZ and read replica. I'll answer that question in a minute. Okay.
Sure.
So with there is a concept called multi-AZ. So what it does is essentially, so by default, your database gets created in one availability zone. But if you choose to have a multi-AZ feature and all of your production databases, invariably you want to keep multi-AZ on, period. As an architect, that's first thing you want to pick it up. So what it does is your primary database is in one availability zone, and your standby database, the way multi-AZ works is that it creates a standby database. It's exact replica standby database. And every single transaction that's happening on your primary database, it will synchronously gets replicated in my standby database. Your standby database is not available for you to read or even to connect to it. It's purely for AWS. In case something happens with your primary database, then your standby instance will be automatically be made primary by AWS automatically. So that is multi-AZ feature, and you absolutely want to have it for every single production database. Synchronous replication between primary and standby. Understand that it's not asynchronous, it's a synchronous replication. So it's pretty much no latency. If primary database fails for whatever the reason, for network reasons, for availability zone being down for brief period, or any of that, it will bring up automatically. It will bring up your standby. It will make the standby as primary. And then in addition to that, it will bring up, since you set up your multi-AZ feature on, so it will automatically make the standby as primary, and it will create one more standby and then start replicating into another one. If things go south on this existing one. Does it make sense? And understand going into the exam, for both for positive scenarios and also for elimination purpose. Multi-AZ is not for performance improvement. You will never ever be able to log into your standby instance. It's there only for disaster recovery reasons. Okay. So
and this is also within the Venkat, this is also within the what is it?
Free tier?
No, within the same region only, right?
Yes,
you said
that's
the
correct.
same location.
That's correct.
Yeah.
Multiple availability zones within
Availability
the same
zones
region.
only.
Yep. It cannot
obviously,
cross multiple regions.
Yeah.
There is only Amazon Aurora. Amazon Aurora has this. Amazon Aurora or the other one, DynamoDB. They have a global database concept. Only Amazon database supports it. No, none other. It's a region specific. All of them.
Yeah, and another one is like obviously synchronous means like it will impact the performance, right? Is it how big difference is like? Is it negotiable or like?
It's like you know, it, by the way, it does not do anything fancy there. It uses the underlying engine's capability for the replication.
Yeah.
If Oracle supports one way, so there's no silver bullet there. Amazon doesn't do anything you know, magic here. It relies on Oracle's replication strategy.
Gotcha.
It relies on MySQL replication strategy. It relies on Microsoft SQL Server's replication strategy.
But
If that underlying engine happens to be slow, unfortunately, this stays slow too.
Yeah, I mean, general, like obviously, I think maybe they might tune it very well for cover the all kind of scenarios. But in general purpose, like we tune based on our needs and situations.
Right.
When we implement that, now we don't have control, right?
Right.
So,
no, you do not have any control. Absolutely not. It depends on the underlying engine.
Yeah. Thank you.
Yep. That's about the multi-AZ. And then there is another concept called read replica. So as I told you clearly, multi-AZ is only for disaster recovery, but for the read replica, it's used for performance reasons. Well, you have a primary database. Primary database is used for both reads and writes. And now what you can do is you can set up, once you create your, once you create your primary database, now you can set up your read replica. It's exact same database, but it's only used for read users. Change your application in such a way that all the writes go into this primary database, but all the read users go into this, they get the data from this read replica. Okay, what it does is every single commit that you make, it asynchronously, it's not synchronous. It will asynchronously replicate into the read replica. So there could be a slight latency in your read. So when you upload a photo here, it gets written and it gets asynchronously replicated in the read replica. And when you try to read it, you may experience a delay of a second. So you can create read replicas from primary database, data synced asynchronously. Please, going into the exam, understand that multi-AZ are synchronous, but read replicas are asynchronous. Automated backups must be turned on for this to work. If you want to do a read replica, your automated backups must be turned on. Understand that going into the exam also. So you can have, once you take the read replica, you can have a read replica of that read replica. You can go into multiple layers there. Make sense? So now when you have your backup, now let's talk about Arun's question, right? So Arun's question was, I don't have a fixed downtime or maintenance window. So how will I be able to do it? What you want to do is, so set up your database multi-AZ. You have your primary and standby, and then you give any automated backup window. It will not take it from your primary database. That's the beauty of your multi-AZ. It will take it from your standby database. So you have zero performance issues there.
Yep, that answers.
Yeah. Yep. So, and it's an important point going into the exam also. I wish I had put it there, but it's thank you for asking. Okay. So now we talked about these relational databases, right? Now Amazon has its own non-relational database. Okay. Oh, by the way, did I mention, do I have a slide for that? In case if I didn't have it. So out of all the 6 database engines, Amazon Aurora can be the only one that can be made serverless. But other than that, all the database engines by default, including Amazon Aurora, of course, Amazon Aurora can be made serverless, but all of them are not serverless. Underlying, there is an EC2 instance. There is an EC2 instance, and all these, you are paying full price for your EC2 instance. Understand that. 24/7, 365 days, whether you use it or not. Now, going into the DynamoDB. DynamoDB is an Amazon's non-relational database service. Okay, this is a completely serverless. You don't have to worry about it. Okay, you will not create a new DynamoDB there. You will create your own table and then start playing with it. That's it. It's a serverless. So it's a lightning fast NoSQL database. It's a single-digit millisecond latency. It's amazing. And it's very important going into the exam that if you ever see the single-digit millisecond, and you should think about DynamoDB. 2 years back when I took it, actually, I made a mistake here. I put Aurora, if I'm not wrong. So I want you to, going into the exam, I want you to understand that. So it's a completely serverless. There is no EC2 instance under the hood, and you are not paying 24/7. There is a separate billing for this. And you create your table. Well, it's a document-based. You know, it's a NoSQL database, essentially. And DynamoDB, it spreads across 3 geographically distinct data centers. It will automatically take care of it. You don't have to worry about any of that. Multi-AZ, any of that. So going into the exam, the most important point is the single-digit millisecond. If you see that, think of DynamoDB. See this? This is the picture for DynamoDB. It's a lightning fast, and it's a NoSQL database. It's a non-relational. Okay, that's about DynamoDB. So, and let's talk about Redshift briefly, and then we jump into VPC. So, Redshift is Amazon's answer for your data warehousing needs, for business intelligence, data warehousing. It's a fast and fully managed data warehouse. So interestingly, it uses, it kind of re-architected, differently. It uses this columnar data storage for efficient storage. It compresses your data so much because it doesn't store row by row. It rather stores all the column by columns, all the columns in one place, the second column in another place, like that. It architected differently. So that's why with Redshift, you have a massive petabyte scale. Also, you could get decent compression on that. And in addition to decent compression, you will also get the massive parallel processing for all of your BI needs. And going into the exam, it's a popular one also, please. Currently, your Amazon documentation clearly specifies that Redshift does not support multi-AZ. So it's a single availability zones deployment only. It does not support multiple availability zones. You'll have to spin up your Redshift cluster in a single availability zone only. Elasticache. So you might know this. Elasticache is an in-memory caching service for super high performance of frequently used stuff. Something like, let's say you logged into Amazon.com, okay? On the left-hand side, you will see the most popular top 100 products or something, are trending products. How many times do they change? They change probably once a day, okay? You don't want to hit the database for that. You want to store all of that information in memory. Okay, Elasticache is an abstraction service on top of 2 in-memory engines called Redis and Memcached. Okay, So Redis and Memcached, they have been there outside of AWS. These are in-memory caching services. So this Elasticache sits on top of it, and you deal with it. It automatically brings your Redis and Memcached managed services for your frequently used data. Expect scenario-based questions around performance improvements. Either you want to go for CloudFront performance, Elasticache performance, and read replica. Multi-AZ is not for performance. Multi-AZ is only for disaster recovery.
So you're saying it's not supports multi-available zones?
Redshift.
Okay.
Amazon's data warehousing service called Redshift currently does not support multi-AZ. It supports only, you can create a Redshift cluster in only single availability zone.
No, this one, the Elastic cache.
Oh, no. This one supports it.
Okay.
My point was for Redshift.
Okay. I'm surprised to see. I mean, Redis is popular, but at the same time, clustering-wise, it's not that great, right? Compared to.
Are you talking about Redshift or?
Oh, sorry, Redis.
Redis, okay.
No, I think when you are saying like the elastic memory, the caching will support across the regions. I'm a little bit surprised by seeing underneath implementation is Redis.
Oh, wait. No. We are sorry. We crossed a couple of boundaries here. So the point I made about was for Redshift. Redshift is a data warehousing service that will not cross multiple availability zones, not regions there. Okay. Understand that?
Yeah. Okay. I was talking more about the elastic.
Yeah. Sorry, 1 second. We'll get there. But we talked about multi-AZ, right?
Mm-hmm.
So my point is for the Redshift, it does not support multiple availability zones. Now the topic is done. Now let's talk about Redis. So when we said Redis, it's obviously within the region only.
Okay.
It's absolutely within the region only. So very few services like CloudFront, like Route 53, very few services like IAM. These are the few services that support, cross-regional.
Okay.
Okay.
So then, okay. Yeah, I got it. No. I'll process that thread later. Takes time.
No worries.
Yeah. So basically, I think majority of them are like within the single region. So you need to architect according to that.
Exactly.
If you're maintaining the cache.
Exactly. So it's 6:41, guys. I need probably good 30 minutes to talk about this complex part. How are you guys doing?
Good.
Can you guys give me 30 minutes? Is it okay? It's okay. No worries. We'll talk about this. The important one, it doesn't matter whether you're using AWS. It doesn't matter whether you're using Azure, Google Cloud Platform, whatever it is, these concepts are critical. So I want to talk about virtual private cloud. It's pretty much having your own data center within AWS.
Yeah.
You can specify your own IP ranges. You can specify your own route tables. It's pretty complicated topic also, mainly because of networking. So networking is not first nature. It's not first language for any of us, at least not to me. So that's why it's little complicated. That's what I feel. So that's why I tried my best to make it easy. We'll see. You will know if I really made it or not. So yep, it's undoubtedly going into the exam the most important topic, period. You will have to be able to do this virtual private cloud without looking at any notes. In and out, every scenario, you have to be able to do it. And then only, you'll be able to pass the exam, period. For all the people who are serious about it. So virtual private cloud is a logically isolated section of cloud just for you, meaning you will have a more control over your network. You can pick up your own IP ranges, your CIDR range, and you can logically group them into multiple subnets. Subnet is nothing but a logical group of IP ranges, right? So let's say you want to keep all of your web servers in one IP range, and you want to keep all of your database servers in another IP range, etc. You will be able to do that. You will get complete control over your networking components, including your own IP range. You can create your own subnets. You can specify your route tables. Okay, I'll mention what's the route table now. I'll try my best to explain it. And it supports both IPv4 and IPv6. Let's take a scenario here. So when you create a VPC, your VPC is within a region. Let's say this is AWS region. Within that, you have 2 availability zones. And then your VPC will span across all the availability zones. Your VPC is within a region also. VPC cannot span multiple regions, period. So here my goal is I wanted to create a brand new VPC. And this is my CIDR range, 10.0.0.0/16. This will give me about 60,000 plus IP addresses. /16 is the maximum that you can go with a single VPC. You cannot go smaller than 16. You can go /12/8. 16 is the maximum that you can go. So you'll get about 60,000 IPs. Now, within that /16, if you guys know what it means is /16, you have your, you have your octets here, right? 10 dot, so your 0 to 255 dot 0 to 255 dot 0 to 255 dot 0 to 255. It's an IPv4, right? When you say /16, so you have your 8 bits. So here you have 8 bits, 8 bits, 8 bits, 8 bits, total 32 bits. So out of 32 bits, you're using 16 bits for the subnet calculations, and the other 16 you're using it for your real IPs. That's what it means. So you are creating it within a region. It will obviously cross across availability zones. So what happens when you create a brand new custom VPC is it will create a router. You will not be able to see it. There is an implicit router there. There is an implicit router. Your router, like your home has a router, right? So every packet that comes in, your router will look at it. Where do I pass it? Where did this request initiated from? Is it from my Apple TV or from my Fire TV or my iPhone? So when a request comes back, my streaming, it will look at it and then forward it to it. So your router will sit there and then look at the route tables and then see where, when you request send out or when a network packet coming in, your router will orchestrate that. So when you create a new VPC, you will get a router. This router is responsible, but you will not see it visually. It's an implicit router. This router is responsible for routing the traffic to various instances. Make sense? Across the availability zones. So you have your router. And then within that, it creates a default route table. So by default, if you look at it, it creates a default route table. This is my VPC CIDR, right? CIDR range 10.0.0.0/16. Look at this one. 10.0.0.0/16 target is local, meaning if this route table is associated to some guy, I'll talk about it, what that guy is. So if this route table is associated, what it is saying here is that within this IP addresses, any request goes into these guys, forwarded to the local. Meaning, what it means is there is a route from every single instance within VPC to another instance within an VPC. There is a route, meaning every single guy can talk to other guy. The route is there. Whether you want to allow it to happen or not is up to you. That's a different story. But by default, that's how the route table is. In addition to that, there is something called, there is another concept like security group called NACL, Network Access Control List. Actually, it's called Network ACL. You don't want to call it NACL, but Network ACL. So by default, it creates a default network ACL. The network ACL is nothing but custom rules, whether you want to allow the traffic or deny the traffic. And these are at the subnet level. Well, what is a subnet? Subnet is nothing but a group of IP addresses. Essentially within your 60,000, your /16 here, right? Within this IP range, you want to give some IPs to your public subnet, some IPs to your private subnet maybe. You want to keep your application servers and database servers in a private subnet, and you want to keep your web servers in your web DMZ. They will be able to take the requests from internet, but these private instances, meaning your database servers, application servers, they will not be able to take the request from internet. They are not exposed. They will only take the traffic from web servers. Fair? It's a fair architecture, right? So just for simplicity, I put it in this side also, on the right side also, because it's a default route table and default NACL. So these two, your route table and default or network ACL, both of them will be attached to subnet. By default, your subnet will not be created. By default, your subnets will not be created. It creates route table, it creates a network ACL, and by default, your network ACL rule says that allow all the traffic to my subnet. So now let's create a subnet. Let's go ahead and create a new subnet. I want to create a public subnet, and this subnet, I want to create it in this availability zone. So going into the exam, the most important aspect is your subnet cannot span your availability zone. One availability zone can have a lot of subnets, but your subnet cannot span multiple availability zones. Your subnet must be zone, period. And I created this public subnet. My IP range is /24, but 10.0.1.0. See here, I've taken the same example as Amazon documentation. They illustrated this example. I've taken the same example. Nothing fancy here. So what it said is 10.0.0.0/16 and 10.0.1.0/24, meaning three bits will be taken for your subnetting, and only you will have the IP addresses. If you want to, if you're curious about what IP addresses it allows, go to this this website called cider.xyz. There you go. So if you provide, it will tell you what are all the IPs it's possible. 10.0.0.0/16. If you do a /16, you will get total 65,536 IPs. Okay, so that's what 16 means. So two of them, 2 bits are completely taken for your subnetting, but the other 2 are available for your IPs. Let's say 10.0.1.0/24, you have your 256 IP addresses. Out of 256, Amazon reserves 5 IPs, so you will get only 251 IPs. And your range, your first IP is 10.0.1.1 to 10.0.1.254. This is the first IP and this is the last IP. So anyways, this is our public subnet. My public subnet, I gave 10.0.1.0/24, right? And I want to create a new subnet in my second availability zone. I created this availability zone. When you create an availability zone, you must select, when you create a subnet, you must select what availability zone it's going to sit in, because your subnet cannot span multiple availability zones. Make sense? And this is 10.0.2.0/24. So you'll get 256 here, but Amazon reserves 5 5 IPs for each subnet. So you will have 251. So you can have 251 within 251 IPs or 251 EC2 instances within your public subnet. And you can have another 251 within your private subnet. And you want to provision all of your application servers in your private subnets or database servers here, and you want to keep your web servers into public subnet. Both of them are same at this point. When I create these subnets, both of them are same. Currently, when a request come to the router will be able to, all I'm saying here with these arrows, I wanted to show that when a request come to router will be able to decide, where does it go. That's all. So now I wanted to show that to start with, when I created my subnet here, it by default attached to the default route table. By default, because the default route table is already created when I created a subnet. It's already attached. So what it means is I will be able to talk to other guys within the same VPC. That's all. I can't talk to anyone outside of my VPC. Outside people cannot talk to me. That's the default behavior. And by default, when I create a subnet, it will automatically be attached to my default network ACL also. And by default, network ACL says that allow all the traffic, meaning there are no restrictions to my subnet is all I'm saying. By default, we will change it. And it's the same thing with private. So this is what happens when you create a new VPC here, guys, within a specific region, and then create a public subnet, private subnet. You did not do anything. That's all you did so far. And by virtue of creating this public subnet and private subnets, they automatically get attached to this. Because there are, it's a default route table here, default NACL, it's already there. Does it make sense at this point? Is it too much?
No, Venkat, so from the public subnet, right? Like, so you'll get the public traffic to web server. From web server to back database or application servers. So you'll go through with the router, but you're restricting.
I did not restrict any at this point. Yeah. At this point, even though I named it as public subnet and private subnet, they both mean the same.
Yeah.
They both mean the same. Public subnet is not public. Private subnet is not same.
Yeah.
Sorry, private subnet is not, both of them are private at this point. Yeah. They can talk to each other. Somehow, if you're able to log into this machine, you'll be able to ping this machine. You'll be able to talk to it, within VPC. Because these are all within VPC, because there is a route to all the instances within VPC, yeah. You'll be able to talk to these guys. But how do I log in? No clue at this point.
Yeah.
Make sense? Let's go ahead and provision couple of EC2 instances. This is where we are. What we'll do is, let's go ahead and provision a couple of web servers into public subnet. When I provision my web servers, I selected my public subnet there. And these are provisioned. And let's provision a couple of app servers in private subnet. I did that. Now, that's where we are. At this point, right? At this point, I know I did not depict here, but this is both the public and private subnets have the default route table and default network ACL, meaning they will be able to talk to each other internally only. But okay, you've been saying it's a public subnet. What exactly meant by public subnet? Public subnet means it will be able to take the request from the internet. Somewhere outside of the region, somewhere outside of the VPC, somewhere outside of, somewhere from the internet, it will be able to take it. Your web servers are supposed to take the request from internet. They're supposed to be in WebDMZ. Does it make sense? Now, how can I make this public? Really, it's a public subnet, but I didn't do anything to make it public. Well, if you really need to take the packet out of your VPC, or let the packet into the VPC from internet, you need an internet gateway. So this is an internet gateway. So now what you'll do is you will create an internet gateway and attach to your newly created VPC. Internet gateway is the way to go out of the internet. So now these instances will be able to go out, not yet, but you have to change your route table. You have to change your route table and give route out or route in. You have to give the route to internet gateway. Then these web servers will be able to talk to internet, or internet will be able to talk to these web servers. Does it make sense? This is an internet gateway. So create an internet gateway and attach to your VPC. Create an internet gateway, attach to an EPC. Now the third step is now create a new custom route table. In this one, the first route is already there, 10.0.0.0/16 local, meaning if you are talking to internally any of these guys, let's say, you will be able to go through this local, this one. But if you are going out, any traffic going out, see here, O.0.0.0/O, meaning anyone, you are going through this IGW, meaning internet gateway, whatever this, there will be an ID here, right? Internet gateway, you will give that ID here. After creating this custom route table, you attach that one to public subnet. Now the default route table, what happened? Your subnet can be associated to only one route table at a time. So you yanked off the default route table, and now you associate it to the custom route table. Now you have a route to the internet gateway. Now it will be able to take the traffic from internet, and internet gateway will take the traffic from outside, from the cloud, somewhere, from your home. Okay. Internet gateway will take the request packet and then give it to the router. Router will say that, oh, okay, see, let me look at the router. Okay, so yes, let me send it to this guy. So you attached an internet gateway to your public subnet. This is how you attach it. Create an internet gateway, attach to your VPC, give a route to your route table, and attach that route table to your public subnet. Look at your private subnet just for a second. It is still with the default route table. It's still with the default route table. It only has route to the local. It doesn't have route to internet gateway, meaning it will not go out and talk to servers in the internet, or internet people will not be able to talk to these guys, if that makes sense.
Yep.
Okay. Now, this is the diagram, right? I want to make it little clarity. I remove this region, I remove this VPC, I remove this availability zones. I'll only keep it, specific to VPC. I'll redraw this one. I'll take out this junk. Let's redraw this for clarity. So at this point, you have an VPC. Within VPC, you have a public subnet and you have a private subnet. And you have your public subnet is associated with the custom route table that has internet gateway, but your private subnet is associated with the default route table. It doesn't have any route out. It only has route to the instances within that are local to your VPC. Only can talk to local. See this one, IP range 10.0.0.0/16 only. Now, also I did from the previous diagram, what I did is I moved this network, network ACLs into public subnet, right in front of public subnet. Network ACLs are police guards to your public subnet. Network ACLs they act as virtual firewalls for the entire subnet. Remember you talked about security groups when we talked about EC2 and Elastic Compute Cloud? Security groups are at the instance level, but the network ACLs are at the subnet level. All the rules will be defined at the for the entire subnet. Let me mute. Can you mute yourself? I hear some background. Okay. So I just redrew this. So now look at it, guys. So this is cloud somewhere from your home. And then when you want to reach out to somebody, let's say this web server here, okay, it goes to the internet gateway. Internet gateway will give it to the router. Router will give it to, it will try to give it to the public subnet, this guy, and all the rules will be applied here. Your network ACL rules will be applied. The network ACL is where all the rules will be applied. You can deny the request from a specific IP, or you can allow, yes, you can allow rules to a specific IP. Okay. You can say that this particular port is allowed, but this particular port is not allowed. You can put all those rules there. These are numbered list of rules. Network ACL are numbered list of rules like 100, 200, 300, or 101. They'll go in a sequential order. And if the first number allows the traffic, then it will let the traffic into the subnet. Okay. So this guy is a police guard here. It acts as a police for the entire subnet. Okay, now that it goes into the subnet, but what happens to the security groups? We talked about security group. Well, the security groups, how about security groups? Yeah, well, security groups are at the instance level. So after the network packet is allowed through the rules of network ACL, now your packet entered into the subnet, now your security group has to allow it. If your security group allows it, then it will go into your web server. If it does not allow it, then it will not. So the security groups are at the instance level. Your network ACL is a front police officer in front of for the complete subnet. Similarly, this is not only for the packet coming in from inside, guys. Even if your web server wants to go out and get something, let's say it wants to patch up the security updates, okay? It passes the security group has to allow it, and then network ACL rules will come into picture, and then there has to be a route, and then only it will go out. So these guys, there is no route out to go out internet. So these app servers will not have internet connection. Similarly, internet will not be able to reach to them. Only these guys will go, because these guys have, this public subnet guys have a route to internet gateway. Does it make sense? I understand if it's too much. I totally respect that, because it's pretty.
This is really good. Question. In a private subnet, if I have my app servers and if I have to update the software,
yep.
If I cannot talk to internet.
Yep. Let's talk about that. So you jumped the gun. So see my next slide. My private subnet needs internet. As Anand said, my private guys, well, I don't want to be in DMZ. I don't want to take the traffic from internet, but I need to go out to the internet though. And so that I'll be able to install my softwares, I'll be able to update my security patches, OS level security patches. How do I get the internet? At this point, there is no route out.
Talk to vendors.
Yeah, I'll talk to the vendors, sure. So how can I get this? At this point, it cannot go out. There is no packet. There is no, in the route table, there is no route out there. What do I do? Well, I don't want to attach internet gateway. One safe option is, one simple option is attach the internet gateway to my route table. Well, it becomes public subnet now, because it will be able to take the packet from internet, not only going out, but I want one directional internet. I want my app servers or these private instances to go out, but they don't want to take the traffic in. How can I do that? Well, there are two ways you can do that. One is called, you have to create something called NAT instance. Okay. You have to create something called NAT instance. You create that NAT instance in a public subnet and give that route in your route table to the NAT instance. What the NAT instance does is, it will do a network address translation. NAT stands for network address translation. Even though the request is coming from here, it will do a network address translation and then send that request to internet gateway, because your NAT instance sent it. So it will allow it. Once it gets back to the NAT instance will re-NAT that and give the packet back to your private subnet. So you have two ways to do that. One is called create a NAT instance in your public subnet, or NAT instance is nothing but a simple EC2 instance that will do the network address translation, and that will be sitting in a public subnet. Okay, and you will attach that NAT instance ID. You will update your route table. Here there will be an additional rule here to your NAT instance ID. That is how these private subnets will go out, but they will not take the request in.
So in the same context, right, Venkat, like, so because like if you go back to your diagram, so because maybe my web servers in public subnet, because obviously VPC is costly, right? So because it's dedicated.
No. Let me correct there itself. VPC is costly, it's dedicated. VPC is completely free. All of this one, you'll only pay for your resources. If you spin up a web server, you're paying for that. If you spin up an additional web server, you're paying for that.
Yeah.
All of the subnets, creation, route tables, all of this is free.
I mean to say that the web server, if I created in VPC, then created in the public is not same cost, right?
It's exactly same cost.
Okay.
It's exactly same cost. You want to keep them private because you do not want to expose them for security reasons. And you absolutely want to make sure that my app servers can take the request only from the web servers, but no one else.
Okay.
Make sense?
So one small question here. NAT IPs, right? So in the NAT generally in NAT instance, and we are going to keep some sort of allowable IPs. So in the similar way, can we design the same thing in IGW? I mean, Internet Gateway. I hope these two plays the one role.
No.
And
Internet Gateway is unfortunately it sits here at the complete VPC level. It will take the traffic in and it will let the traffic out. That's an Internet Gateway. Okay, it's meant to be like that.
Okay.
But your
so you
NAT
mean to say that
sorry, go ahead.
within the networks, okay, if you'd like to allow this the public subnet within the networks, then we will go for the NAT instance. Okay.
The public subnet, they automatically get the internet access because of the Internet Gateway, because you have this route here. You do not want to do that here to this one. They only want internet out, but not in. Internet Gateway will provide both. You don't want to provide both for your private instances. Did I answer that?
That is where I confused, because I worked on one of the NAT instance. That NAT instance allows in and allows out both.
Okay, when I say allows in, let's when I put a NAT instance in my public subnet, make sense? And now I will give this NAT instance, I will update my route table and put the NAT instance here, right? Now, this app server will be able to do a sudo yum update, meaning it will go out to internet, get the security level, operating system level patches and apply that. It will go out, but it has no root in. Absolutely. You install your Apache, you install whatsoever, but there is no traffic in, period.
Question, Venkat. This is awesome. So do we put that NAT IP or NAT gateway IP in custom route table or else the default route table?
Okay, let's talk about it. So one way or the other, let's say, I told you there are two ways, right? One is called NAT instance. Before I answer that, there's one way is NAT instance. NAT instance is a simple EC2 instance that you'll put it out there in your public subnet, right? But EC2 instance can go down anytime. It's a single EC2 instance. You do not want to do that. Okay, if that EC2 instance happens to be down, then I will not have internet for the entire subnet. Rather than using NAT instance, use another solution called NAT gateway. NAT gateway, you don't have to worry about it. Amazon automatically creates that redundancy. And then it creates a gateway. You just create a NAT gateway. It's a redundant, high throughput gateway. You attach that NAT gateway. Again, you're putting this NAT instance on NAT gateway, both of them in public subnet, and you update your route table and put it here. Does it make sense? Now I will answer Anand's question. Okay. Now, so Anand's question is, do I want to do that in the custom route table or default route table? There is already a custom route table here, right? This one, let's call it public route table. Okay, let's call it public route table. And this one, let's call it private route table. So now you do not want to, you can add your NAT instance or NAT gateway here, but you don't need to, because you already have internet gateway attached to this. You already get it in the internet, both in and out through this one. So you want to add it to your custom route table. Sorry, you want to add it to your default route table and update it.
Okay.
Or leave the default route table as is and create one more route table called private route table. And then one way or the other, you just add that additional rule that o.o.o.o/o to my NAT instance ID, or o.o.o.o/o NAT gateway ID. I will give that. And once you create that route table, you can only associate one route table to your subnet. So it doesn't matter which one you want. Does it make sense?
Yeah. So in a VPC, we can have as many as route tables we want.
Yep.
So for each subnet, we can have only one.
You absolutely can. If you have a more than one scenarios like that, absolutely you can.
Right. Okay.
But all maybe food for thought. Maybe all of your private subnets want internet. Maybe you just purely based on your context. But maybe all of your private subnets want internet out. They all want to, they all need internet to patch their operating systems. So maybe you need one route table and attach that one route table to all of your private subnets. Maybe. Or maybe not. If it's a different use case, but you can attach one route table to one subnet. But you can create that one route table now attached to all of these guys. But your subnet cannot be associated more than one route table.
Perfect. Awesome. This is wonderful.
Thank you. Okay, so. And after creating the NAT instance and NAT gateway, go update your route table here, and then you'll get internet out. And update your route table to add a route to NAT instance and NAT gateway. So going into the exam, use this high resilient NAT gateway instead of NAT instances. NAT instances are simple EC2 instances. They do not have any resiliency. If EC2 instance is down, if your NAT instance happens to be down, it's just another EC2 instance. If it's down, then you will lose internet for the entire private subnet. So think about it. You want to always use NAT gateway. Okay. Oh, looks like I did that. See here, what I did is I created a NAT gateway here in my public subnet. Okay, and I took that ID and I updated the route table here. I updated the default itself, saying o.o.o.o/o NAT gateway ID, whatever this ID, this guy here. So when you are trying to go out, when you try to go out and get, go to the internet and get the packet in to update your security patches, then it will be given to the network gateway. And this network gateway must be in public subnet, either network gateway or NAT gateway or NAT instance. It must be in public subnet, because all it's doing is simple NATing and then giving the packet out to the internet gateway.
Yeah, because private can talk to within the VPC.
Now the next question you want to be able to answer is, well, we got internet to this guy, right? This guy will be able to, update its OS level security patch. Beautiful, I love it. Now, let's answer it. How do I log into this private subnet? I want to be able to SSH into it. From my machine, I want to be able to SSH to my app server, right? Okay, it's getting internet through NAT gateway, beautiful. I'll be able to do a M update, to update my security patches. How do I able to SSH into it? Well, you can't, because there is no public route. How do I do that? Well, you have to log into one of the instances in your public subnet, and from there, you have to log into your private subnet. There is no other way. You will not be able to log into your private subnet, period. Does it make sense? You will have to log into this one of the web servers here, or create a brand new instance. They call it Bastion servers. It's a simple gem box instance, essentially. All it does is it's a simple EC2 instance. It's a simple EC2 instance. Okay, you log into that EC2 instance, and there is a small technique called SSH agent forwarding. Okay, there is a tool called Pigeon in Windows, and in Mac you already have it by default. You can use a special SSH command. So through agent forwarding, SSH agent forwarding. Before agent forwarding, let me step back here and make a point here. From internet, you can log into one of these servers in the public subnet. From here, I can SSH into this one, right? But still, to SSH into this box, you need to have your private key. Because Amazon supports only key-based authentication, I need private key. So I have two options. I have to copy my private key into one of these instances into my public subnet, and then SSH into it. That's a lousy idea, right? I don't want to copy my private key into one of these boxes because this guy happens to be in DMZ. It can take threats. What if somebody hacks into it? They get my private key and host. So don't want to do it. So we rather want to use this technique called SSH agent forwarding, and that's called Bastion host. Essentially, it's a simple web server or one of the servers, simple EC2 instance created, and then what you will do is you will forward your private key into this one, and then this guy will forward that private key into this. It's like a key chaining concept. So log into your public instance. If you want to log into your private instance, log into your public instance. From public instance, log into your private instance. And you do not want to copy your private key into your public instance. Rather use your SSH agent forwarding. Well, there are a couple more concepts: VPC peering and direct connect and VPC endpoint. But I think it's a lot. It's fair to stop here because I think you showed quite a bit.
Absolutely, Venkat. I think lot to digest and lot to process, right? So, do you think like maybe we can have one more session next week? Maybe
Definitely.
Quick 45 minutes or maybe one-off session.
Yeah, definitely. I was thinking about actually, containerization and ECS, Elastic Container Service. Things that I've not covered were Route 53. I did not cover. At the high level, at least, what is a containerization and what's this Docker, Kubernetes, and then what Amazon has to offer: ECS. Elastic Container Service and Kubernetes Service, and then there is an abstraction service called FireGate on top of it. I was thinking about that, and then also API Gateway and Lambdas. I don't know how much I can cover in one session, but give me 1 more hour. I'll see.
Absolutely. So I think like maybe before we get into the next steps and also a quick feedback on today's session, I would like to share a story with everyone, guys. Is that okay, Venkat?
Yeah, absolutely, Vamsi. Thank you.
Anyone knows this guy? Anyone?
No.
No, Vamsi. I do not.
So you might have heard about him several times. His name is Pablo Picasso.
Oh, yeah.
So everybody knows who Picasso is, right? He's a great artist from French.
Yeah.
So one day he was walking in the market. One of the royal family member from Britain visiting France and she was in the market. She saw Picasso and said, "Mr. Picasso, I'm a big fan of yours. Can you just draw a picture for me?" He said, "Absolutely, that's my privilege." And he took his pen, he drew a picture in 30 seconds and gave it to her. She immediately said, "Wow, this is amazing. This is like maybe the best picture." And she was started walking away. And Picasso said, "Mrs. Young Lady, this is $1 million. Then she looked back and said, "You draw this in 30 seconds. Why it's $1 million? Then he replied, "Miss Young Lady, I spent 30 years of my entire life to draw this picture in 30 seconds. The reason I'm telling this story, whatever that Venkat shared now, you can look at the screen, because of his 20 plus years of hard work behind the scenes. I really wanted to take some time and give, this is not just happened overnight. This is not just happened in the last 6 months. This is ridiculous work behind the scenes for 20 years. So I call Picasso is a great artist. I also call Venkat a great artist too, because he loves his craft. It doesn't matter. He's like maybe delivering for 45 minutes or like a 4 days. When he's working on his heart, he worked like a Picasso. Just wanted to say we're all really grateful for you, Venkat.
Oh, thank you so much, Vamsi.
Yeah, that's really true, Venkat.
I don't see any difference between the photo 20 years back versus now.
I was thinking otherwise, like it's a lot of change.
Now,
Senior version over here now.
So Venkat is getting younger and younger every single year, right? And also, like most of you are part of high performance mastery. You all know the tips and tricks that Venkat shares throughout his journey. So yeah.
Absolutely. Thank you,
Excellent,
Venkat.
guys. So let's take like maybe a few minutes. I know Venkat has been talking for last like maybe 150 minutes non-stop. So you take like maybe 60 seconds and explain like how this session helped you. What are the things that you got clarity on? Because once you share, other people also learn from you, and also you're going to be retain that information for a long time. Make sense?
Yeah.
Who would like to go first?
I'll go first. Yeah, Venkat. It was an amazing session, a lot of learning. I think I was very, very interesting in the VPC area. We talked about the last portion of the discussion, the most important area. So I really appreciate, because I have been spending a lot of time, and this is a time consuming area. So yes, definitely heartfelt thanks to you. It does explain a lot of criticalities in terms of overall architecture and the approach towards it. So thanks a lot.
Thank you. Thank you for the kind words.
Same thing, Venkat. Like you are very clear, crisp, clarity, detailed, and you have like going through this documentation takes a hell lot of time. Like, and you're summarizing it, and that summary gives you a lot of clarity, and also maybe sometimes people spend in particular topics and digging into it, and may not get chance to end. Or sometimes they are doing it, they might have questions, may not be answered quickly. And you are giving clarity of that for a lot of people. Yeah, that's very good. Like, thank you so much. And I was also listening very carefully on that last topic, VPC. We have Azure, and we have this VNet injection and VNet integration in Azure. So I'm trying to compare that. Thank you really so much. And you are really passionate about it.
Thank you. Appreciate it.
Thank you, Venkat. You built up that VPCs, that is a little complex part of complete AWS. So VPCs, subnets, gateways, and how they are interacting, and then so you built like example, and then you expanded it. That is very useful. That sounds to be perfect way of architecturing the example and the concepts how you should be explaining. I really liked it. I was watching other videos, but here I got the more intricacy and details in it.
Thank you, Srinivas.
I have already given my feedback at the first session. I'm echoing that, and now I would like to give a small compliment saying that you are the best.
Thank you. Thank you. Thank you.
And Vamsi, if you allow me, I would like to share the one more story, which is similar to the incident that was happened to Picasso.
Sure, go ahead, Nara.
Okay, this is a real thing that was happened. I hope most of the people know Indian politics. You know, right? I mean, I'm not going into the politics here. Just wanted to tell the incident to give the value of the Venkat's time and as well as his knowledge. Okay, so there was a famous cinema actor in Telugu industry. His name is Chiranjeevi. Of course, he has a different name originally. So he started a party called some Prajarajyam. Prajarajyam is a very big concept, and but of course, I mean, the one day, you know, Yandamuri Virendranath, he's one of the famous author in Telugu, and he was traveling in the train, and someone came to the Yandamuri Virendranath, asked about the Prajarajyam party. So since Chiranjeevi started that party, so how that is going to be? Is he going to be win, or is he going to be? I mean, he's going to become a chief minister. So then this guy, the Yandamuri Virendranath, asked him, saying that if you give me 100 rupees, I'm going to give you the answer. He said no. So okay, if you give me 50 rupees, I'm going to give the answer. He hesitated. He asked 1 rupee to give the answer. Still he hesitated. So so that means the discussion stopped over there. So what happened is, so that means the Yandamuri Virendranath thought that, okay, this guy, if I give the answer to him, and the answer what I'm giving to him is not going to value, because the value of the answer is not going to be worth even 1 rupee. So what happened is, finally there was no conversation because there is no worth for it. I mean, the discussion went, because if there is no worth and you are not supposed to discuss it, okay, you know, right, what happened, the later the elections, everything went, if he would have given 100 rupees or 50 rupees or 1 rupee to Yandamuri Virendranath and get his answer, and the guy who was asked that answer, right, that guy would have saved minimum 10 crores. I'm not going to tell the name, but he's one of the MLA and who has contested towards the Congress party. He lost his the win. So I mean, what I'm trying to tell here is, if you really need an answer, use it. I mean, respect his time, and because we are not paying anything here, use his whatever the speech that he has given. So use this and write the AWS certification. And don't think that since he has given on free of cost, and we don't need to like open this and learn. I hope this helps.
Inspiring, Nara.
Right.
Sorry.
And
thank you, Nara.
It is almost 2.5 hours. It's almost the length of any Bollywood movie. So that much time it's like he spent on it. Heroes take crores for entertainers 2.5 hours. So yeah, we will respect Venkat's time and his experience and all that. It is not just 2.5 hours. It's a lot more than that. It is how much you spend your historic time. However, of course, it is going to magnify 100 times into our future and our careers. We are very grateful for the sharing knowledge today. Thank you.
Yeah, actually, I came to know this the real incident from one of the close relative, and of course, I'm also a little close relative to Roshi Agaru. So, and that's the reason I'm sharing this. And thanks for giving me an opportunity, Vamsi.
Sure, Nara. Good story. Anyone else would like to
Yeah,
share?
I can go. Okay. Venkat, I mean, everybody teaches AWS. You can go to internet, right? But then the difference here, right? The industry experience you're sharing, right? That's more important. Everybody wants to go to cloud just because it is a buzzword, right? And then they end up, burning their hands and all of that. Because if you don't architect it right, you're gonna have more cost and maintenance and all of that, right? So the way you explained, right, and those are really good. Not just best practices and also context-based stuff, right? And I don't think you get that kind of inputs by reading books or watching like videos. Awesome.
Thank you.
And yeah, you touched in depth from a knowledge perspective and also like exam specific stuff, right? Especially CloudFront is something we don't use it on a regular basis, right?
Right.
But still you get at least 3 or 4 questions around that topic. So you just nailed it. It is a great content. Thank you.
Thank you.
Thank you so much, Venkat, for your time. You covered like all the topics in depth really well. I just wanted to say one word: you are a walking dictionary.
What's that? Sorry, I didn't.
Walking dictionary.
Oh, thank you. I'm not, but thank you.
He ran
No way.
Running dictionary.
Maybe walking cloud. Excellent, guys. So I think like most of you part of like a high performance mastermind. I saw a couple of people, Srinivas, Sindhu, Geeta, Varma. We all like meet once a week and we discuss about like a lot of things. Part of that group is to learn things and implement things like maybe that typically takes about 10 years in less than 6 months. So if you are interested, maybe what I can do is I can schedule a call with you, and also I can spend like maybe 45 minutes with you one-on-one and see if there are like maybe any opportunity for you to join in the group. So yeah, it's up to you. I just wanted to share that option with everyone. Venkat, with your permission, I know you.
Absolutely, we highly recommend that. And we are the benefactors who have been being, I'm almost one of the beginners from the beginner day one, and will always be. So it's I'm the biggest fan.
If anybody wants to know about the experiences of might call me. Yeah.
Yes.
My number is 248-631-8225.
Thank you,
sir. If you believe in exploring yourself,
yeah,
I think you should do that. And it's a transformation, right? And yeah, you would start loving it. You will never regret this kind of decision down the line in your life. This would be the best decision you can make.
I'll just have one more point to add to it. What we talked about, just for example, if you want to learn swimming, the best way to learn swimming is not to go and read the ebooks, not to go and read everything and know everything about swimming. And when you get into water, you cannot swim. The best way to is jump in, let the process take its flow. I have been in touch with Vamsi, and these couple of last 3 months have been one of the biggest disruptors. A lot of changes that I see very positive. So I would definitely recommend talk to him. He's best in the area.
Thank you, Amit. Excellent, guys. So I'll be posting this recording into Dropbox. I know a lot of content in very short time. You may need to go back and listen multiple times. So do that. And the next week, Venkat, do you think like 5 o'clock next week?
Yeah. Sure, Vamsi. Yeah, 5 o'clock.
So it will be like a 5 o'clock Eastern time. We'll meet again. Again, thank you, Venkat.
Thank you, guys.
Thank you. Bye-bye.
No worries. Thank you.
Thank you.
Again.